Hello, everyone. Welcome back. Made it back to our next session for the LAC Summit. And it's so great to see everybody come back again and some new faces for these really great learning opportunities. So as many of you are aware by now, my name is Emma Burns. I am the coordinator for professional learning at the Learning Analytics Collaborative, which is the host of this event. And if you're interested in what the Learning Analytics Collaborative does, we are a service and a product for schools that help you to create cultures of data use and help schools and teachers to make impact and make meaning from the data in their schools. So if you're at all interested in that, we'd love to tell you more about it. You can reach out for a demo call. But one thing that's a really important part of what we do is the idea of a collaborative. And that's what we're really celebrating today, sharing schools in our collaborative and their data journeys and how far they've come. And someone who knows more about this than just about anybody else is our next speaker, Kevin Crouch. He is currently the head of EdTech and IT at Western Academy of Beijing. But previous to that, he's worked with a number of schools, helping them to build their data culture. And he even worked at LAC, supporting schools with building their data dashboards and with their professional learning. And so I'm delighted to hear from him and hear all about what he's been doing at WAB in regards to data literacy. So thanks so much, Kevin, and over to you.
Thank you, Emma. That was quite the intro. Yeah, I want to say thanks for this opportunity to be here and to contribute to this summit. And I also like to apologize for my somewhat Spartan surroundings. I didn't put a background on just to kind of try to keep the data transfer down to a minimum because I'm sitting in a hotel room in rural China right now on a service trip, and so this is stretching the limits of technology, but it looks like it's working. So loving that. Anyway, as Emma said, I'm at WAB currently. I've been here for 4 years. We're about 2.5 years into our LAC implementation, and it took us a little while to get up and running, and I think I think there's a lot of reasons for that at WAB. And one of the reasons is that I think a school, what I've learned from working with a lot of schools is that your people at the school kind of have to be ready to know what to do with the data when they get it, right? And so we did a lot of work ahead of time on looking at our existing data sets that we had, helping them understand what they meant, before we threw out a whole bunch of visualizations at them. And so one of the outcomes that here are the outcomes that I hope to get through this evening, if the internet holds up. And then, essentially identify what some visualizations are and how are they chosen to represent data, reflect on some common misconceptions about data, and consider the training your faculty might need in order to get up to speed to be able to use the tools, any tools that they might have at school, but for the purposes of this call, especially the Learning Analytics Collaborative and the visualizations that are there, right? So we're going to look a little bit first at data representation basics, because really there's been a revolution, in the last 20 years around how we are able to look at, digest, right, and interpret data. And so, we're not talking about just plain old bar charts and pie charts anymore, right? There's some really cool stuff out there. But we do have to know why some of these things are chosen, and what purpose do they serve. So we'll start with just thinking about these 3 big bubbles. So a visualization is usually chosen for purposes of organizing data in a way that is really visible on one screen, right? So obviously you can't show a massive data set on one screen to be able to communicate that to people. So you got to organize it some way in a nice type package. Next, we want to, really good visualizations do that and allow you to compare different data sets, different control factors, and things in one nifty little package. And then, of course, we want to have visual impact. We want the things that we want to communicate, we want that to jump out, right? And have an impact on the viewers for that. And so we'll look at some ways that that's done. And first, we'll start with essentially what essentially amounts to looking at the same data in two different visualizations. And so as we go through this, you'll see these are examples of little kind of warm-up exercises that I'll often use and run with teachers before we do a data dive. And so we have on the left a chart with a bunch of dots, right? And on the right, we have what looks like a bar chart, right? So there's a special term for that bar chart on the right. Does anybody in the room know who doesn't work for the LAC what these two charts are called? Go ahead and yell it out if you know. All right. Well, if not, okay. The one on the left here is called a scatter plot, right? And that makes sense when you hear it, right? It's just a bunch of data points scattered around. And the one on the right is called a histogram. And both are looking at map data in this particular case. And, here on the right, we're looking at absolute number. That's what's important. You want to see a count of certain people that performed at a certain range, right, or a certain number. And you can see that as you go up here. On the left, it's not as easy to see the absolute performance number. What's most important here is the relationship between, in this case, it's between achievement with the RIT score and growth. So all we have to do is add one more data point in there, and we can see a completely different view of the data that we weren't able to see over here. But both of these are very meaningful, right? So on the right, this histogram would normally tell us whether we have a normal distribution of data in our set of data, whatever we're looking at. In this case, of course, it's assessment. And we'll look at this a little bit later. If anybody knows, they can say, what is the impact of having this kind of long tail on one side of an assessment chart? That we'll talk about a little bit later. But on the left, we're able to see two dimensions. So achievement and growth. And this is able to tell us whether or not, regardless of what their achievement is, whether or not those people that achieved at a high level were also growing, right? Or those people that achieved at a lower level were also growing. So that's the difference between these two things. All right, now we'll look at bar charts, and bar charts seem pretty simple. We just looked at one, right? This, of course, is what we call an area bar chart, and an area bar chart is designed to help us see it's designed to help us disaggregate the data in one measurement, right? So now we see three different populations or three different factors or whatever it might be that's in there. What about the one on the right? How is that different from the one on the left? Anybody throw a guess out there? How is the bar chart on the right different from the one on the left based on what you can see? If you see percentage points, that's what's different here, right? So again, when you have a bar chart that's meant to give you absolute values, sometimes that doesn't give us the full story. So we want to be able to see, in this case, we want to see how each of these measurements and how each of this disaggregated data shows as parts of a whole, right? So if we're looking at the total of 100%, we can now accurately see which of these measurements has a higher impact or a lower impact when looked at from a percentage perspective. What percentage of the population, right, was impacted the most or the least by a certain intervention? Versus going over here to the one on the left, where we have to actually try to extrapolate and say, well, there's not as many people in that population. That green bar is a little smaller. Would it be, would it be bigger if there were more people? It's hard to know, right? So using percentage, what we call a percentage area bar chart, lets us better see when something has a bigger impact relative to other types of interventions. Okay, so that's just looking at two different bar charts. So you might see these things floating around. Sometimes it's really helpful just to understand what it is that somebody's trying to convey when they use one versus the other. All right, now let's look at pie charts. So you've probably seen these donut charts before, right? And wondered, why are they using a donut chart when it just looks kind of like a pie chart, right? Well, basically, that's all it is, and it's a more modern version of that. But some people might wonder if they're trying to convey something a little bit different, right? And in some cases, they are. But if you just look at the pie chart on the left, pie charts are designed to give you a better sense of that part of the whole. Like the sense that like you have all of the measurements in here and you're showing, all of them together, and which of the samples takes up most of the pie or least of the pie. Problem is, it gets very challenging when the pie pieces get really small and you try to fit a lot of different samples in there, right? So over here on the right with the donut chart, you can see it kind of spreads it out a little bit. Actually, even though this one doesn't show it, it looks better when you have smaller slices in there. It also focuses you more on the relative sizes of the different pieces of the donut, right? I mean, you might ask, how are these things both similar? I mean, they are both food related charts. So, okay. But really, if I'm looking at a donut chart, there's another thing that a donut chart does that might cause somebody to use that one. And that is, we're not going to look at this one for very long because it is challenging, but you can nest multiple donut charts into one to see how different trials or different factors may have influenced the measurements that we're taking, right? So this is what we call a nested donut chart. So if you have, people at your school that are throwing around different visualizations, they don't appear to be the right purpose for that, hopefully you can have a conversation and let them know what might be the better use for that. All right. So we have, this is a slide that I use almost every time I'm working with teachers and we're about to look at data. And this is a data visualization, right? This is, okay, it's a tennis court. There's a net and there are tennis balls on that court. And this is a literacy. When we're talking about data literacy, we're also talking about the literacies that we need to be able to have a conversation around a data set, right? To be able to collaborate around data. So how do you talk about this? How do you talk about data, right? So this, I usually throw this out there to try to get people to make inferences before we really should be making inferences. Because when you look at this, all you can see are tennis balls on a court. People like to throw out this notion that, oh, it looks like one player is better than the other, right? But we don't know that. It could be somebody practicing their serve. It could be anything, right? It could be a coach hitting really hard balls at a player who's unable to get them back, right? So, we have balls that are in different quadrants in this visualization. We have a distribution. We have all kinds of words that we can pull out and look at here. And it brings it back to the human aspect of things where we want to immediately jump and make an inference about what we're seeing. And so it forces us to slow down and just think about what is it that we can see, observe only, and not what we can guess is happening, right? Okay. So another visualization that we need to be familiar with when we're working with assessment data, especially, right, is what we call the box and whisker chart. And what this shows us technically is, it's based on a 5-number summary, right, where you have your minimum, your first quartile, your median, right? So the median is right there in the middle of that box, not right in the middle, but it's the line that separates that box in two. Your third quartile, and then your maximum. And to interpret this information, that median line inside the box is the middle value of the data, right? It shows the central tendency, right? So this is a graph about time slept and the days of the week. So we can instantly look at this and see some patterns in how people sleep. I don't know where this data came from. But for example, we can see that Friday and Saturday, it looks like the boxes in the middle, the two middle quartiles are bigger than on Wednesday and Tuesday. And what that's telling us when we look over here is that our median sleep pattern is 9 hours on Saturday and just over 9 hours on Friday, whereas on Wednesday, it's only 6.5, right? Well, it also shows us this concept of variability, right? So we can see that the two lines, the maximum and the minimum, are also much farther apart on a Saturday and a Sunday versus a Wednesday and a Thursday. So variability is another key term. And when we talk to teachers about their assessment data, for example, often they want to go right in on means, right? They want to go right in on the maximums, but they may not think about just how variable those data sets are and what that actually means. We also have what we call outliers, right? These little dots at the top and the bottom. And these outliers are also really important for us to be able to determine if there are people that need additional support, or if there are certain factors or times of the day, times of the year, where we get more outliers than we would normally expect to have, right? All right, so this is a box and whisker plot, and these are super useful for conveying variability, right? Okay. So the next thing we're going to look at here are common misconceptions, right? So when I was working with schools on their data sets, especially when we start talking about the data, it's really interesting to see just how a few misconceptions can really change the conversation that we're having about learning with about our kids. So the first one that we're going to look at is correlation versus causation. So correlation simply shows that two variables move together, but it does not mean that one causes the other, right? So for example, high attendance and high achievement might be correlated, but other factors like socioeconomic status could influence both of those. Versus causation. And we often want to jump into cause, right? When we're talking, when we're looking at student data, people want to say, oh, that's because, or that's because, right? The truth is we can almost not ever know what the cause of a certain, data result is, especially in a school. There's just way too many factors. So we want to make sure that when we're looking at data sets, we're especially talking about correlation and not causation. So you need a pretty rigorous scientific approach to prove that any one particular change or any one particular factor is going to cause that effect. So here's an example. So this is from Statista. So this is the relationship between drowning deaths and ice cream consumption by month in Spain, right? So drowning deaths being in the purple, ice cream consumption being in the red. So, well, we can see that ice cream consumption peaks in April and May, and drowning deaths peak in at the end of June, in early July. So one might say that, wow, okay, there's got to be a relationship there, right? But chances are both of those things are also correlated with better weather, more people going into the water, and maybe the peak of holiday season is the only thing those two have in common, right? So we just need to be careful about drawing inferences. Two things that are correlated do not necessarily have a causal relationship, right? Okay. So the next one we're going to look at, this is another misconception, is the mean versus the distribution, right? So when we're talking about means, so averages can mask significant differences in student performance, right? If one student scores extremely high while others perform poorly, the average might look fine, but the student could still need extra support. So when we're looking at distribution, we're talking about variance, and variance can dramatically influence the mean. So an unusually high amount of variance may mean we are not serving the whole population equitably, and outliers might reveal a student excelling or struggling for reasons that should be explored. So one thing that we'll look at to illustrate this is this concept of mean, median, and mode. This is a very important literacy concept here. So, because often people just want to jump and think about the mean. It makes sense. All right. Well, when we have perfectly symmetrical data, and I think about that histogram chart that we had earlier on, that mean is going to fall right in the middle of that data set. But if we have positively skewed data, that means that we have a larger number of people at the lower end of whatever we're measuring. And it slowly tails off on the higher side, then our mean is going to be higher, right, than the median. And if it's negatively skewed data, where we have more people on the lower end of whatever we're measuring, then the mean is going to be lower than the median. And this can be quite a dramatic separation between these two, right? So the median is the exact middle number between all of the measurements. The mode is the highest number. So, that mean doesn't necessarily tell us a whole lot if more of our kids are kind of clumped up in one area, but then you've got this really strong distribution over a long way that's going to pull that mean down. So we need to be very careful about how we look at and talk about mean, median, and mode. All right. So another concept that I find teachers get kind of mixed up in is this concept of percentage versus percentile, right? So, I mean, you really have to practice talking about percentile for it to kind of make sense. We all know what a percentage is, right? So it's usually we're talking about an achievement or a growth amount level for a kid. How much did they grow? They grew by 20%, right? Or, some people might talk about how they were better than 75% of the class, right? Well, percentage and percentile are close, because if you say that, what you're saying is that they're in the 75th percentile of the grade, right? So this is a ranking. And when we talk about percentile, really we're putting that student's performance in the context of other students' performance. And we can talk about percentile when it comes to achievement. We can talk about percentile when it comes to growth. We talk about a lot of things, right? And so often a teacher will talk about how they don't like ranking kids. This comes up a lot, right? Oh, we shouldn't be talking about ranking. It's not about the rank, right? Well, it kind of is important in a lot of assessment data. It's hard to get around because their performance is reported often in percentile. And so if a student is growing at a certain rate, but they're not growing as fast as the rest of the class, right? Then that means their growth is going to be in a lower percentile. And so, and they might actually be fairly high in their achievement, but they're not growing. And so we want to make sure that we actually honor the context of the other students that are in that sample when we're talking about our students' performance as well. Okay. Getting up to my 30-minute limit here, and then we'll take questions. So the last concept, of course, and this is related to some of the other concepts I was talking about, is this notion of significant versus meaningful, right? So if you're not a statistics professional, if you're not teaching a class on, if you're not a scientist, then we might throw around words like significant, and just because something looks like there's a difference. But significant is in scientific terms is pretty specific, right? So we're really talking about differences, more than 5%. So anything between 1% and 5% are generally considered insignificant, could probably totally random, right? Differences. And even if something is significant, it doesn't actually mean that it's meaningful, right? We may never know the cause. We may never know whether or not we could recreate it. So a meaningful or practically significant difference refers to whether the difference is large enough to matter when we take in multiple factors. So if something is truly meaningful, then we should see it again if we do it next year with a different group of kids, even in a different context or a different scenario. And so that takes time, right, in order to do those studies and determine whether something is actually meaningful. And this is really only important when you're having collaborative conversations around data and somebody throws something out and says, hey, this is, I did something and it was really significant or really meaningful. And you don't want to shoot them down, but you just want to probably have that conversation about, we wouldn't say that about your student's performance if a student's performance went down, right? We might say it if it goes up because we're really happy about that. But we just kind of have to keep looking at the straight and narrow and not getting too involved in whether something is a scientific achievement, right? So, okay. So that was all of the slide information that I had for you. So I'm happy to just take any questions that you might have. If anybody's still out there, throw a question in the chat. And if not, that's fine too.
Thank you so much, Kevin. It's really great to see like all those things that teachers might not be aware of and getting that idea of what are the important pieces that and the important skills that teachers need to have before they start diving into some of the analytics that schools are beginning to expect of teachers without maybe realizing that they might not have those basic skills.
Correct.
So thanks for like bringing those to the fore for us.
Yeah.
Yeah, if anyone's got any questions, please pop them in the chat. As people do that, I had a question for you. At WAB or at other schools, what's the context in which you roll this kind of stuff out? Do you have like a data literacy training session, or is it more when you're looking in your data windows? How does that work?
Right. So I think yeah, number one, you have to have, and Walter just asked a similar question. What's the teachable moment, right? Do I like call people in and say, let's have a training session on data? Generally not, right? So usually what we're doing is we're actually going to start looking at some of our data, some of our assessment data, right? We might have map data out on the table. We might have the WIDA scores and student support services out there, right? We're looking at that. We usually do a data warm up, right? So I'll have some of these slides out and about. These are actually real, some of these are real slides. Some of them I created for this, but where we just have we learn something, we put a visualization up there and talk about what it means, and it jogs the memory because teachers aren't thinking about this stuff, right? Statistics is something that, and data analysis is something that's not on on their daily routine. So just having that little conversation, and I find that I would say probably 95% of teachers are pretty rusty at this stuff. Before they start looking at data, and they quickly pick it up because like, oh yeah, I learned that, I remember that, and they just get those concepts and those terminologies down. And it just would take about 5 to 10 minutes before you do some type of a data workshop with teachers where they're actually looking at real assessment data and do this kind of stuff. And I think it's really helpful.
I love the idea of a data warm-up actually,
Yeah.
and using some of those funny graphs that you showed, but using those as that teachable moment.
Yeah. And then, Walter also asked how and where does it show up in the course of a year, right? So it really depends on what we're looking at. So our student support services will usually gather together twice a year to just kind of have a little powwow about how our interventions are working, right? And in what ways, and what, especially just looking at our students of concern. And so that's a real opportunity because these professionals, they care deeply about data. Actually, they just haven't had a lot of opportunity to look at it because the data is really the only way for them to see um, in sort of objective terms, what impact they're having, on a day-to-day basis. So that group of professionals is really important to your school. The other time is we've had a few PD days where, let's just get out the map scores, just lay them all out. In fact, we don't have the digital version up and running. We usually just print them out because we don't want clicky to kind of get in the way of us having a good conversation about what we're seeing. So we'll create ahead of time. We'll create kind of big paper charts that have some map scores on it. We'll put some questions on there, and we'll just give them pens to kind of draw and mark stuff up, right? And think about, and these are printed out LAC visualizations usually, right? Not always, but what else?
Great. And oh, Andy has a question too. Do you find that teachers default to a certain type of visual?
Yeah, I think yeah, right. So it's these take time, right, to grow into, to understand, to be able to just kind of look at it and say, oh, I know what that's supposed to be telling me. So I would say that anything that just is very linear, teachers gravitate towards those, right? They like lines, they like bars, they like anything that easily shows a difference between two things. When you have to really unpack what one little part of a visualization actually means, that's where you lose people, right? So, but even then, I think I found, like I was, for example, with when just talking about the bar charts, right? Often we get stuck even just trying to understand what this area bar chart, this percentage area bar chart is trying to tell us, right? Because people often, they're used to seeing a bar chart where all the ends of the bars are not aligned. So they like these, but when you make the ends all the same, they don't understand exactly what it is they're looking at. So you have to take some time to unpack that we're actually trying to show the relationship between these things, between these groups within, not just the final number that they're pointing to at the top, right? So, and
Kevin, do you find sometimes there's some challenges with that with teachers? Like I'm thinking about teachers that maybe have a bit of fear of data or um, overwhelm, that sort of thing. Is that something you come across a lot?
yeah, yeah, no, I definitely, like I said, I think, we're not, teachers aren't really trained, to look deeply at data. So it takes time, right, for them to learn these skills. And that's why I chose this. I'm passionate about this subject because, teachers collect a ton of data. They do, and they enter a ton of data all over the place. But we haven't necessarily put the effort into growing the literacy skills and conceptual understanding to be able to actually use that data effectively, right? And we can't just all live in sort of bar charts and pie charts all the time. Um, we have to get kind of sophisticated sometimes to be able to show the relationships that we're trying to show. So yeah, I think we have science teachers, math teachers that are great with this stuff, but sometimes they're off, they're kind of too far ahead, right? And so, they have a harder time communicating what they're seeing with some of their colleagues. Or they know some, especially in the elementary school, they know just enough to be dangerous, right? And I don't mean that to be condescending, but it's just, they'll pick on something that they learned somewhere along the line, and really it's not representing their students' story very well. But they've had enough data training to think that they know what they're seeing, right? So yeah.
Yeah, I'm thinking too about in addition to maybe not having the skills, also having some of those like emotional fears about it. I think sometimes data can be scary and people can have um like real trauma from being judged for data and things like that, that is perhaps something to unpack when looking at this as well. What are people's resistances to looking at data, and how do we make it a safe space for teachers to look at, as well as um, having those skills to be able to do it
Right.
in a meaningful way.
Yeah, I just had this
I really,
conversation with
that's
some
not a
teachers the other
question.
day.
I'm just talking at you.
Oh, yep, yep. No, that's fine. I was just going to say that, I mean, there's a question, I think. And, so what's the root of that? Oh, we could probably talk about that for hours, but, I was having a conversation with a group of teachers just the other day, and we were looking at grades for the first time in the visualization in the LAC, right? And I mean, like I said, they've been putting these grades into Power School for 10 years, and they've never actually seen all of those grades for that particular learner or those groups of learners presented in a way that was actually meaningful. Um, and so we were talking about, okay, how well do you really know your kids, right? If you haven't seen their whole data story. And they like teachers feel very strongly that they don't have to spend that much time with a student to feel like they know them, right? That I get who you are as a learner, right? I know you, and they really pride that human connection with their learners. And often they feel that, and I mean, we all feel this, right? That when you put them down in numbers, somehow it dehumanizes them. And I think that's the fear, right? Is that we just dehumanize our population of learners. And I hope we don't, disagree with that. I mean, sorry. I hope we disagree with that to a certain level, but that we also recognize that our kids are more than just a bunch of numbers, right? So that's not the business that we're in. But we also have a lot of biases as human beings, and it worries me when a teacher says, well, I've taught this kid for 3 weeks. I know them, right? Well, okay. They also have 8 years of really good data at the school that might help you know them a bit better. So, have a look at that, right? But
Absolutely. And Walter has another question in the chat.
yeah.
Beyond the literacy and understanding the data, how have you supported teachers in using it to make decisions?
Oh, that's a good one. So supporting teachers and using it to make decisions. So I think, the holy grail in data and analytics, right, is that you might be able to gather a data set about student performance and then quickly differentiate learning for those kids to meet them at their just right level, right? That's the holy grail. And we're still not there yet, at least, not at WAB. And maybe there are some schools out there that are doing that, but the type of data that we're getting back is either, maybe a little bit just too stale by the time we get it to make, quick fire differentiation decisions. But, I think what we have especially found useful is when we look at our different populations of kids and we look at how they are growing, especially, and are our accommodations and our learning strategy, teaching learning strategies in the classroom serving all of our students equally well, right? So we know that one strategy might work great for 10 kids, but it may not work great for all 80 of your kids. 3 strategies might cover half of your kids, right? So, and this is what I'm working with our learning support team on right now is what strategies do we choose for the different populations of our kids based on what we're learning about them? This is the universal design for learning concept, right? So those are the daily decisions that teachers are making that are quite stressful, that sometimes our data can help us make, because we can actually see how all of our kids are responding on some type of standardized test. That's one thing. We've made curriculum decisions, right, a few times, not at WAB yet, but at other schools. Just looking at how it just turned out that different teachers were using, different curricula for one grade level, and you could really see the difference between the kids' performance. And so they made a decision to get rid of this particular curriculum set that they had. There are probably other examples out there, but yeah, I
No,
think
that's
decisions are probably not the ultimate end goal, right, of most using data use. What I would say is the ultimate end goal is knowing your population of learners and how best to support them.
absolutely. You made me think of two things that I want to make sure people know as well. The first is that Matthew Savage is talking exactly about that tomorrow afternoon. He's going to be looking at how we use now my internet's not working. How we use data to know our students, but without reducing them to numbers. And so I really recommend that everybody goes to that one because it's going to be great. And the other one, in terms of thinking about having real-time action, kind of linked to Walter's question about using it to make decisions and seeing the results of those decisions. Ben Marsh talked this morning about the data that they have using LAC for the last 4 years to see the value of the different interventions that they made. And it was really interesting to see. So I
That's
checked
great.
those two out. Yeah.
Cool.
If anyone has any other burning questions, please ask them. Otherwise, I'm going to stop the recording and thank Kevin for his time. And